horse dial, and I'm going to lower it down with my head down low so I can see where it's at. And when I get close, and I feel like I'm as close as I can get without touching it, and then I'll use my small dial. And at some point I won't be able to see in between anymore. But what I can do is I'm going to start watching the panel. I don't really know if I can verify if they're in contact or not. So I'm going to switch over and start watching the panel instead. I'm going to balance the load so that it's at 0. And then when I start to see load recognized by the equipment, then I will determine that that's where contact is. So I'm going like little tiny notches with the fine gauge. Okay, I just went way over. Okay, so you can see we went from very, very low to all of a sudden there's a load there of 0.3 pounds. And that's exactly the point where we want to start. I'm going to call that 0. I'll balance the load. So I'm also going to balance the gauge. And anything we do from here on we'll read as deflection in the center of the beam. Okay? You can see that the readout is taking data. At this point, you don't see any change in the bending. And you'll notice that the values on the computer are live and they're being recorded and plotted in real time. Okay, so I'm gonna let this go for a little while, and then I'm going to reset the camera so that it's directly on the beam itself. And again, this is the low carbon steel. Are you starting to see a little bit of bending or deflection in this specimen? Now here's the question, how do we know, or how does the computer know when to stop the test? When the specimen breaks? Do we expect this specimen to actually break? What do you know about low carbon steel and the properties? Let's pretend this was a piece of glass. How would you expect the glass to fail? This one probably will not fracture. So how do we know then when to stop the test? Let's flip over to the screen and take a look at the data for a second. We've now passed the elastic portion of the curve where you had a linear response, and we're starting to go nonlinear, which means there's damage occurring inside the material itself. And as you look at the beam, it's more clearly starting to bend, starting to fail. So, how do we know when it's done? the nice answer is the computer stops it for you. In this case, it read that the load dropped off really quickly and it stopped the test. Did it fracture? So let's take a look at it. I'm going to move my load cell up. And I'm going to see that, there we go. In fact, this did not fracture at all, but it is quite bent. And even, let's see if I can get this with the back. It's bowed out on the edges a little tiny bit. You see it? So there's been some interesting deformation. Those are the types of observations that you're going to want to record, as well as make sure you take pictures of your specimens before and after so you can properly write reports later. Well, that's about it for now. Good luck.